Hi guys, welcome back to my channel. In this video we evaluate the integral of this rational function x squared all divided by x minus 1 times x squared plus 1. So let's delve into that. This one we can use partial fraction to split the expression. The expression x squared over x minus 1 times x squared plus 1, we can use partial fraction. So the first one, this is how we split it, a over x minus 1 plus, this is like a quadratic term, so the numerator should be a linear term, bx plus c all over x squared plus 1. Then we can simplify this one out. So x squared over x minus 1 times x squared plus 1 is equals to a times x squared plus 1 plus bx plus c times x minus 1 all divided by x minus 1 x squared plus 1. The numerator can be simplified as ax squared plus a plus bx squared minus b plus c x minus c all over x minus 1 times x squared plus 1. So x squared over x squared x minus 1 times x squared plus 1 equal to, can group like terms, ax squared plus bx squared This is ax squared plus a plus bx squared minus bx. There's x here, sorry about that. So we are grouping like terms, ax squared plus bx squared minus, let's say, plus cx minus bx plus a minus c all divided by x minus 1 x squared plus 1. So x squared over x minus 1 times x squared plus 1 is equals to factorize x squared out, and leave it a plus b times x squared plus factorize x out, c minus b times x plus a minus c all divided by x minus 1 times x squared plus 1. The denominators are the same. The numerator should also be the same. So how we make that the same is to compare the numerators. Comparing the numerators, a plus b is the coefficient of x squared in the right hand side. That should be equal to 1. That is the coefficient of x squared in the left hand side. Can call this equation 1. Next, the coefficient of x in the right hand side is c minus b equal to the coefficient of x in the left hand side is 0. There's no x term in the left hand side in the numerator, so that should be 0. Last, call this equation 2. Last, the constant term a minus c is equal to 0 because there is no constant term in the numerator in the left hand side. So a minus c equal to 0. Can call this equation 3. Now we have to solve these three equations simultaneously. So solving equations 1, 2, and 3 simultaneously. So I'm not going to do that. I will just give you the values for a, b, and c that will satisfy all these three equations. So a is half, b is half, and c is half. Plug that in. It works. So a is half, b is half, that is half plus half should be equal to 1. First equation is satisfied. C is half, b is half, half minus half is 0. A is half, c is half, half minus half is 0. So it satisfies all the three equations. Now that we have a, b, and c, we can plug them back into our original equation. When we started first, that is this equation. So x squared over x, our equation x squared over x minus 1 times x squared plus 1 equal to a over x minus 1 plus bx plus c over x squared plus 1. That can be simplified as a is 1/2, b is 1/2, c is 1/2. So x squared over x minus 1 times x squared plus 1 equal to 1/2 times 1 over x minus 1 plus 1/2 into x plus 1 all over x squared plus 1. So instead of integrating this equation, which is not integrable from the look of it, we are now going to integrate this equation, which I think is integrable. So let's split that. So the integral of x squared over x minus 1 x squared plus 1 dx should be equal to the integral of 1/2 1 over x minus 1 plus 1/2 x plus 1 over x squared plus 1 dx. So we can split this into 3 parts. So first 1/2 is a constant that one can come out of the integral sign. X minus 1 plus, this can also be split into 2 integrals. That should be plus integral of x over x squared plus 1, or should be dx here, dx plus the integral of 1 over x squared plus 1 dx. So all multiplied by half. So I can call this I1 integral 1, integral 2, integral 3. So let's tackle the first one. I1 is equals to the integral of 1 over x minus 1 dx. This is just by using u-sub. You can do that quickly. Let u be equal to x minus 1 du dx is equals to 1, implying that du equal to dx. So it means wherever we see dx, we just plug in du. So our I1 is now integral of 1 over x minus 1 is u, and dx is du. And we are integrating 1 over u du, so that's just the natural logarithm of u. Well, what is u in terms of x? Because we have to move from the x, the u world, into the x world. So that should be the natural logarithm of x minus 1. So that is the answer for integral 1. Let's look at integral 2. Integral 2, I can do that in red pen. Integral 2 is equals to the integral of x over x squared plus 1 dx. The same u sub, let u to be equal to x squared plus 1. Du is equals to 2x dx. So we can split, can divide here by 2x, divide here by 2x, and have dx to be equal to du over 2x. So our integral 2 is equals to the integral of x over x squared plus 1 is u times dx is du over 2x. These two x's cancel. We are left with 1/2, which is a constant, comes in front. Integral of 1 over u du. That should be half natural logarithm of u. Now what is u in terms of x? U in terms of x is x squared plus 1 from our u sub. That should be 1/2 natural logarithm of x squared plus 1. This is a positive term, so there's no need putting it in absolute value terms. Next, I3. Let's do that in green. I3 is integral of 1 over x squared plus 1. I3 is equals to integral of 1 over x squared plus 1. So this is a trig sub. Can let x to be equal to tan of theta. The theta is equals to secant squared theta, meaning our dx is equals to secant squared theta d theta. So we can move everything from the x world into the theta world. Integral of 1 over x squared. X is tan of theta squared plus 1. Dx is secant squared theta d theta. That should be equal to the integral of 1 over tan squared theta plus 1 times secant squared theta d theta. From the Pythagorean theorem, one of the trig identities, secant squared theta is equals to tangent squared theta plus 1. So it means wherever you see tangent squared theta, we just plug in secant squared theta. Our I3 now becomes integral of 1 over secant squared theta times secant squared theta d theta. The secant squared theta will cancel out, that left with integral of 1 d theta. We are integrating 1 in the theta world, that is just theta. But what is theta in terms of x? We can scroll up a little bit. We can get theta in terms of x. From here, x was equal to tan of theta. So in that case, theta is equal to the arctan or the tan inverse of x. So our I3 is equal to the arctan of x. Now let's put everything together. The I1, I2, and I3, and our integral will become, so the integral which is here, the integral of x squared over x minus 1 times x squared plus 1 dx is equals to 1/2 into I1, 1/2 into I1. What is I1? So this was what we are now splitting. So 1/2 into I1. I1 is natural log of x minus 1. I1 is natural log of x minus 1 plus, what is I2? The answer for I2 is 1/2 natural log of x squared plus 1. That is 1/2 natural log of x squared plus 1 plus I3. I3 is the arctan of x plus c. So we can distribute the half in. So our integral of x squared over x minus 1 times x squared plus 1 dx should be equal to 1/2 natural log of x minus 1 plus 1 over 4 natural log of x squared plus 1 plus 1/2 arctan of x plus c, a constant of integration. And with this, you are done. This is the value of this integral. So we can verify that. If you want to verify that that is the answer, you can differentiate our answer 1/2 natural log of x minus 1 in absolute value terms plus 1/2 natural log of x squared plus 1 in parentheses plus 1/2 the arctan of x plus c. If you differentiate this, we are getting back our original expression, x minus 1 times x squared plus 1. So that's it. Hope you find this video helpful. Give me a thumbs up, subscribe to my channel, hit the notification bell for more content. Thank you very much for watching the video, and I'll see you in the next one.